Good day, students. In this video, I will show how to solve some selected questions from chapter 12, Progressions, 12.2 Geometric Progressions. A direct sales company started with 3 members in the first level. Each member in the first level is required to recruit two new members to form the second level. So they have first level 3, and then they have to recruit 2 new members, second level. Similarly, this goes on with each subsequent level, assuming that all the members manage to recruit 2 new members each. Find the number of members in the 5th level. Okay, I'll just illustrate this a little before we try to solve the question. So first we have 3 members. Okay, maybe I'll start with, okay, so we have 3. Then these 3 members will recruit 2. Okay, so this is first level. Here's a pen, first level. Then they recruit 2. This becomes the second. Okay, and then it keeps on going. This one recruits another 2, 2, 2, 2, 2, and 2, and that becomes the third level. Okay, so it goes on. Now they're asking you to find the number of members in the 5th level. If you keep on drawing what's the number of members in the 5th level, but you can do that without drawing. This is just to illustrate, give some brief idea what's happening and how does it work, but we will use a formula to find the value. So the first level we have 3. Okay, continue by the second level we have 1, 2, 3, 4, 5, 6. We have 6. The third level, if you want, you can count that too. 2, 4, 6, 8, 10, 12, and so on. So your A is 3, your R is 6 over 3, T2 over T1, and you get 2. Now the question asks you to find the number of members in the 5th level. That will be T5. Use the formula AR to the power of n minus 1. 5 minus 1 is 4. What is your A? Your A is 3. What is your R? R is 2 to the power of 4. You get 3 times 2 to the power of 4 is 16, and that is 48. Okay, so the number of members in the 5th level is 48. Continue with question B. The total number of members in the company when the 8th level is completely formed. So the total number means sum. They want you to find the sum. Okay, so it's sum of 8th level until 8th. So what's the formula to use? Okay, your R is 2, more than 1. Therefore, we'll use the formula A, R to the power of n. N is 8 minus 1, R minus 1. Okay, what is your A? A is 3. R is 2 to the power of 8 minus 1, 2 minus 1. Who can see that? Yep. So use your calculator to multiply. So 2 minus 1 is 1. You can ignore that. 2 to the power of 8 minus 1 times 3. You got 765. Okay, moving on to the next question. Rearrange the paper. Okay, good. An electronic company produced 100,000 units of television in the year 2001. Since then, its production has been constantly increasing by 8% annually. Find the number of units of television it produces in the year 2006. So the first year is 2001, and after that it increasing 8% annually. Okay, so the first year is 2001, that's 100,000. And this is T1 or A. Okay, and your R is increases increasing by 8% annually. Increases, that means it's 100 plus 8%. So you can change that to fraction, you get 108 over 100, or decimal 1.08. Now ask you to find the number of units of television it produces in the year 2006. So the first year is 2001. Okay, the first year is 2001. So 2006 is the 6th year. First year is 1, 6 is the 6th year. So you need to find the 6th term, T6. Formula is A R to the power of n minus 1. 6 minus 1 is 5. What is your A? Your A is 100,000. What is your R? Your R is 1.08 to the power of 5. Use your calculator to solve this. And you'll get 146,932. Okay, it's a 0.8, but since this is a number of television, you can't have a 0.8 television, so you can either have 32 or 33, but we can't take it more than what's given in the question, so we'll take 146,932 televisions. Okay, so for question B, if the company targets to achieve a total production of more than 1 million units starting from the year 2001, by which year will the company begin to achieve this target? So they want a total production. Total production means sum. So they want it to be more than 1 million. So your sum Sn is more than 1 million. 1 million means 6 zeros. Okay. So what's the formula to use? Your R is more than 1. So we use A R to the power of n minus 1, R minus 1 more than 1 million. Okay, what is your A? Your A is 100,000. Your R is 1.08 to the power of okay, that's what we want to find, n minus 1 over R is 1.08 minus 1 more than 1 million. You can see that. Okay, we move on to the next part of the paper. Use a different pen, different color. So it's B, still B. So I'll try to solve this equation. I'll bring before that I'll just cut the zeros to make it more simple. Actually, when I bring it over here, it'll become a division. I can just eliminate the zeros. I get 1 2 3 4 5. I can cut 5 zeros here. 1 2 3 4 5. It's just 10. So I get 1.08 to the power of n minus 1 over 1.08 minus 1 is 0.08 more than 10. Okay, how do I get 10? Because of the elimination of zeros, I get 10. Just bring 0.08 to my right, becomes 1.08 to the power of n minus 1 more than, becomes multiply, becomes 1.08, and 10 multiply 0.08, you get 0.8 minus 1, bring it here, plus 1, get 1.8. So I'll take log on both sides. Take log base 10 on both sides. Okay, so it's LG 1.08 to the power of n more than LG 1.8. So I'll bring the index to the front since it's a log, and LG 1.08 more than LG 1.8, and bring it to my right, the LG 1.08, so you get LG 1.8 over LG 1.08. Now I need to know whether LG 1.08 is positive or negative. I'll just use the calculator to find out. LG 1.08, it's a positive number, so the sign won't change. The sign remains the same. Okay, so solve this through calculator. So LG log base 10 1.8 divide log base 10 1.08 and get n more than 7.64. okay, n is more than 7.64. so in the year of 7.64, which is bigger than 7.64, the company will achieve 1 million. So the smallest number after 7.64 is 8. So I can write here, in the 8th year the company achieves 1 million set. 1 million sets. Okay, so it's the 8th year. Okay, moving on to the next question. The diagram, okay, I'll just rearrange the paper so that you can see better. Yes. The diagram shows a plant with 2 branches at point A in the first week, 2 branches. After the first week, this is point A and 2 branches. After the first week, every branch produces 3 sub-branches. So every branch produces 3. Find the number of sub-branches the plant produces in the 6th week. Okay, so the first week it has 2 branches. The first week it has 2 branches, followed by every branch after the first week every branch produces 3, followed by 3 branches in the second week. So we have 1, 2, 3, 4, 5, 6. Followed by the third week we'll have 3, 6, 9, 12, 15, 18, and so on. So this is our week 1. This is our week 1, okay, which happens to be our T1 or our A. Okay. Now the question asks you to find the number of sub branches in the plant produces in the 6th week, T6. So T6 equals to AR to the power of n minus 1. 6 minus 1 is 5. A is 2. R is 6 over 2 to the power of 5. 6 over 2. T2 over T1. So 2, 3 to the power of 5. I'll use calculator to solve this. So you get 486. That's the number of branches in the 6th week. Moving on to question B. The minimum number of weeks for the plant to have a total of at least 105,000 branches. So they want a total. Total means sum and the number of minimum weeks. Minimum number of weeks. Okay, so your B, your SN, at least. So they want at least 1,500. So SN is more than 1,500. So what is the formula for SN? I'll use the formula. You can see this. Okay. A R to the power of n minus 1 or minus 1 more than 1,500. What is your A? Your A is 2. What is your R? Your R is 3 to the power of n minus 1. 3 minus 1 more than 1,500. Okay, I'll jump to the other part of the paper. I'll use a different pen. Still doing B. Okay, so 3 minus 1 is 2. 2 and 2 you can cancel off. So you get can see 3 to the power of n minus 1 is more than 1500. This becomes 3 to the power of n is more than 1501. How? I bring negative 1 over to my right, it plus 1 and becomes 1501. Now to solve this, I'll take log both sides, log 10 both sides. So I get log 3 and base 10 more than log base 10 1501. I'll just remind you, if you are taking log base 10, you can just simplify that, right? LG represents log base 10. Okay, so it's faster for us to do the calculation. So for a log with an index, you can bring the index to the front. You get n log 3 more than log 1501. So n is log 1501 over log 3. So just want to make sure log 3 is positive or negative. I can check that out with my calculator. Log 3 is a positive number, so the sign will not change. So I can use my calculator to solve that. Log 1501 divided by log 3 and get an answer. N is more than 6.66. That means at the week 6.66, the number of total branches is more than 1500, but I don't take the week 6.6. Should be a round number, so I'll take the smallest round number after 6.66 is 7. So I'll say in the 7th week total branches are more than 1500. That will be the answer. Okay, that's all for this video. See you again in the next video.